Okay, so in this video we're going to talk about parallel circuits. So for parallel circuits, there are individual branches, and so we've got a 9-volt battery, and then I've got a 1 ohm resistor, a 2 ohm resistor, a 3 ohm resistor, and a 1 ohm resistor, and these are each their own parallel branch. So this is a parallel circuit. They all connect independently to the voltage source. So if one of these were to turn off, the others would be fine and they would continue to work. So oftentimes for these types of problems, they're asking us to find the total current, that's the current that flows through the battery, as well as the total resistance for the circuit. And there's two ways to do the total resistance. I'll show you how to do them both. It's important to note too that the total resistance for this circuit will be less than the smallest resistor. So for this particular parallel circuit, it will be less than 1 ohm. So in order to find the total current, one of the ways that we can do that is we can find the current in each of the branches, and we just use Ohm's law for that. And then what we do is we just add them all up. So there's 3 branches for this one. So the first branch is, we'll just write it as I1. We'll use I equals V over R. And this is the first current, so we use the first resistor. And the nice thing about parallel circuits too is that there's no voltage drops, it's just the same. So you don't have to calculate voltage drops, you just have to write whatever the voltage of the battery is. So we've got our 9 volts, and we've got our 2 ohm resistor. We get 4.5 amps of current in the first branch. We'll do the same thing for the second branch using Ohm's law. I equals V over R. So I2, we'll find that by 9 volts. Divided by our 3 ohm resistor, we get 3 amps in our second branch. And we'll do the same thing for the last branch. I equals V over R. This is the third resistor. So we've got 9 volts divided by our 1 ohm resistor. We get 9 amps of current for the third one. So to find the total resistance, we just add them all up, right? So I total would be I1 plus I2 plus I3. So we have 4.5 amps plus 3 amps plus 9 amps. We get 16.5 amps of current. That's what's flowing through the battery, right? So the first resistor has current that flows around. The second one has current that flows around, and the third one does too, and they all get added up as they go through the battery. If we have too much current that flows through the battery, you might need to put a fuse, and the fuse can either go here or it can go here. You have to put the fuse before you get to the first resistor. So you could put in a fuse on this side, or you could put it on this side. You don't need 2, you just need 1 of them. That way there, if there is an overload and the current and the circuit breaks in either of these locations, all the branches will turn off, right? That's where we put our fuses or circuit breakers. So to find our total resistance, we'll call this one option 1. And all we have to do, now that we've found what our total current is we use Ohm's law, and we'll just solve it for resistance. So R equals V over I. So if I want the total current, I have to use the total resistance, I have to use the total current. Sometimes it's also called equivalent resistance. So I have my 9-volt battery divided by my 16.5 amps, and I get 0.55 ohms. So we'll call this option 1. We don't have to use anything else other than Ohm's law once we have the total current. There is another option. So option number 2 is we can use another equation similar to what we use for the series circuit for adding up all the resistors, but this one is 1 over our total is the sum of 1 over R. So that looks kind of funny. And so what we would do for this one is this would be 1 over R1 plus 1 over R2 plus 1 over R3. So to get our total resistance this way, we don't need the current, we can use all the resistors that are there, but it will be 1 over 2 ohms plus 1 over 3 ohms plus 1 over 1 ohm. If we add all those up, we've got 1/2 and 1/3 and then 1. We get 1.83, but the units are wacky, right? The units are 1 over ohm. So we don't want 1 over ohm. So in order to get our total, we have to do 1 divided by 1 over 1.83 per ohm. And so that will give us 0.55 ohms. So we can get the same answer using a different equation that doesn't require us to find the total current. So that's another option. You don't have to use that way. You can still keep using Ohm's law. You can use Ohm's law for any of these circuits. So that's it. Now that's how we do our parallel circuits. And I will see you in class.